Okay, very good. Okay, so cathode is negative, very good. And my negative releases hydrogen gas. Okay, if you can't say it out loud, I am very happy when you're able to put it in the chat. Okay, very good. Okay, so you get that concept. Okay, so this is the electrolysis process that we are going to do on Friday. Long line, long line is positive, short line is negative. Long line, Puan Shina told you just now. What's the name of it? Remember POW?
Pao
Chinese.
and Chinese New Year.
Yeah, so the long line is called what?
Cathode. Wait. What cathode? Oh, yeah.
The long line is positive. So positive is? The positive is what?
Positive is not just
Correct. Positive is anode. Very good. Okay. Now this negative here is called
cathode.
cathode. That's why teacher wanted you all to memorize POW and Chinese New Year. Okay. Now in the cathode, what gas is going to be released?
Hydrogen.
Hydrogen. Okay. Now doesn't have to be Vignesh alone. Anybody else can answer. So, okay. In the anode, what gas is going to be released?
Oxygen.
Oxygen. Okay, very good. Okay, good job. All of you even typed that. Teacher's very happy. Okay, good job. Okay, so I think roughly you get the idea here already. This is what you're going to get. Okay, what's the point of electrolysis? Electrolysis is very simple. Teacher got water, or I've got any other substance, and I want to break it down to its constituent elements. That means I want to break it down to its elements. So here my elements are hydrogen and oxygen. So what I want to do is I want to break it down, and only electrolysis allows me to break it down. Okay, so this is why teacher is undergoing electrolysis. Okay, so let's do a test together. We've done for the first one. Okay, so go to class point. Okay, hang on, yeah. So my question to y'all is, what gas in the anode and what do you use to test oxygen and hydrogen? Now, some of you not giving me the correct answer. What did I use to test?
Teacher, I can't see the answer. Not sure why.
You can't see the answer. You need to write down the answer for teacher.
I mean, I can't see the question.
Okay, Naman, you listen to my question. Yeah, my question is, what do I use to test for oxygen? What do I use to test for hydrogen? What splinter am I using for oxygen?
No, teacher, I mean, like, what is this? I
Oh,
can't, like,
you cannot go into class point, is it? Are you already in class point?
I'm already in class point, but the only thing I'm seeing is like the electrolysis and then the Sheena, ESMK, Sultan Abdul Samad, safe slide and all the stuff for me.
Class, how about the rest of you? Can you see the question?
Can teacher?
Jonathan,
Yeah.
you try again.
Ask him to refresh the tab.
Jonathan, you refresh, Jonathan. Pranat, you trying or not, Pranat? Okay, is anyone else trying? If not, teacher will close the submission so we don't waste time. Teacher only got 45 minutes left, okay? Okay, actually you can use class point. You can, not a problem. But it's okay. Pranat, if you can't, you just type in the chat, teacher's happy also. No problem. Okay, I'm gonna close submission in 5, 4, 3. Oh, Jonathan got it. Okay, Jonathan. 2, 1. I'm gonna stop, yeah, because it's not enough time. Okay, never mind. The next question you can try. Okay, I'm gonna put all your results in my slide. Then I can check your word one by one. Nah? If you look at teacher's screen, okay, Shami says electrolysis. That's how I test. Okay, Shami, tak salah jawapan tu, tapi dia tak lengkap. Okay, cikgu bagi setengah markah saja. Okay, Sarvin said anode and atot. Sarvin, what is atot? Okay, no problem, no problem. Oi, no teasing one another. Okay, it's okay. At least he was trying. Some of you maybe first time using class point. Saravana say electrolysis also, but incorrect. Yeah, teacher asked how to test them. Yeah, it's okay. Today we learn new things. Okay, so Emmanuel says for oxygen, I use glowing wooden splinter. Yes, the keyword is go. And for hydrogen, I use burning, correct. You can remember Lucas High. Okay, another word for lighted is here. Okay, I look at Rosie. Oxygen, I use glowing. Hydrogen, I use burning. Okay, also good job, Rosie. Okay, Vignesh. Wait, I don't know why I can't see Vignesh's full answer. Okay, Vignesh said the splinter will have a squeaky pop sound, wooden splinter. Okay, but he didn't tell me what splinter, so teacher cannot give marks. Vignesh must be more careful, Vignesh. Vignesh, did you hear teacher, Vignesh? Okay, all right. And then we go on to the next one. Okay, Amma says for oxygen glowing, for hydrogen burning. Okay, good job. Okay. Oops. Hydrogen. Shubhan, look at hydrogen. Shubhan say hydrogen, it extinguishes a glowing wooden splinter. Class, can you tell me if his answer is correct or wrong? It's meant to be burning. Okay, so good. He can correct his own mistakes, correct. Okay, so Irfan says glowing, burning, correct. Hi, teacher, I got it. Yay, good. Okay, anyway, for the rest of you here, so teacher forgot to put. And then Don Brandon says glowing. This one is incomplete. Okay, but at least he tried. Okay, so I think all of you get the picture. Let's go to the, my screen is all black. Pranat, why don't you log out and log in again? Try again, okay? Okay, so I have a next question for y'all. My soalan kedua. Okay, my soalan kedua is, what gas in the cathode and what gas in the anode? Remember POW, Chinese New Year. Chinese New Year. POW, Chinese New Year.
Teacher, draw on the slide.
You can draw on the slide. You'll have never used class point before, huh? Okay, good job. Some of you given the answer already. Good. The rest of you can try as well. Teacher will wait for you. First slide, teacher go slow. Second slide onwards, teacher go faster already. Am I waiting for anyone else? Okay, good, Shami. Also correct answer. Okay, good. Janardan, H2, Janardan. Never mind, later teacher correct for you. Anyone else still trying? Okay, good job, good job. Very good. So at the back of your mind, or if your notebook is in front of you, okay, I want you to take note, okay? Or write down there, Pao, Chinese New Year. Okay, so all of you will remember. Okay, so teacher saw everybody's answer. All your answers are correct. Okay, am I waiting for anyone else? If not, teacher will close submission. Well done. You all understand the second subtopic here very well. Even though we didn't do the experiment, you all are very clever children. Huh? Teacher's proud of you. Okay,
Teacher,
anyone else?
teacher,
And
it
now,
was actually very hard for me. Teacher.
very hard to write, is it, Janardhan?
Yeah, it was hard for me to write the name, so I just wrote the
It's okay,
symbol.
Janardhan. It's okay. So not quite easy if you're not used to it. Okay, don't worry. Teacher's gonna close submission, going once, going twice, done. Okay, and I will put all your results in my slide. Okay, so in future when I teach my kids next time, other kids, okay, they will see all your answers there. Okay, does anyone have any questions for this slide or for this subtopic? If not, teacher will go on to my next subtopic. Anyone has any questions? Okay, there are a few things that I want to mention to you all before I go on. Yeah, on Monday, Vignesh and Emmanuel, can you collect after your class? In class, Emmanuel, teacher I want you to take the Conquer book, and I want you to discuss all the answers in chapter 5 for teacher and get everyone to mark with their red pen. Vignesh and Emmanuel, can you help teacher with that?
Teacher.
Can. That means by Monday's class, the first period, everybody's chapter 5 must be done. Okay, we have some people coming. Nazis coming. No mind. Emmanuel and Vignesh teacher will explain to you all later. So by Monday, all your Conquer books must be marked on chapter 5. After you're finished marking, Emmanuel collect everybody's book and put it on my table for teacher to sign. Okay, is that clear for everyone?
Teacher.
Okay, excellent. Okay, all right, now teacher is going to go to my next subtopic. Okay, and the subtopic will be, okay, I also can't remember what's my subtopic. Okay, let me go and see what am I going to teach you all after this. Okay, wait, hang on, oops. Okay, let's see. Okay, this is quite an easy subtopic. Okay, evaporation of water. You know, sometimes when we want our things to go fast, it goes slow. You want something to go slow, it goes fast. Yesterday when teacher had class with my Form 5, my pen didn't want to work. Today, my laptop wants to go slow. But you know what? In life, we must always be happy and smile. Okay, so let's talk about evaporation of water. Can anyone tell me something? What do you know about evaporation of water?
So, for example, like drying our clothes.
Correct. Okay, drying our clothes, good example. Okay, so because this topic is so easy, right? So teacher's just going to go slightly faster. It's actually when liquid turns to gas. Is it the same with boiling or not? Hair dryer, very good. Yeah, it is. It's same with boiling, but it's slightly different. Yeah, slightly different from boiling. Because evaporation happens only at the surface. Okay, but boiling happens, okay, for the whole water. Okay, very good. Yes, correct. Okay, Vignesh. Okay, so if you look at my diagram here, okay, we learned that evaporation happens only at the surface of the water. Okay, and it changes water to water vapor, and it's at any temperature. Okay, and if you look at the diagram teacher has here, okay, the molecules of water at the surface only here, yeah, you look at the surface, they will have very high kinetic energy. So they are moving faster and they can escape into the air. Okay, so you look, okay, these molecules of water, they're escaping into the air. Okay, so remember, evaporation only happens at the surface. The one that you see in red, those are your keywords. Okay, and then water changing to water vapor. Okay, now how what affects my rate of evaporation? How can evaporation become faster? Anyone?
The heat.
Very good. Heat. So temperature. Good job, Lucas.
Teacher, the humidity.
Humidity, correct. Vignesh, surface area, correct. One more. Okay, it's the wind, yeah, correct. Okay, so all the answers given are correct. Okay, so I've got 4 factors here: humidity, my temperature, the surface area exposed, and the movement of the air. So later I will also tell you why sometimes your parents doesn't like you to put the clothes to dry, because sometimes you don't dry it properly, then the clothes don't get dried faster. Okay, how many of you are like that? Your parents always say, hey, you're putting the clothes to dry very badly, do it again. Anyone like that? Huh? Yeah, okay, so very honest. So today we see how we can make your parents happy. Okay, see, in science, they teach you how to make parents happy. Okay, okay, so let's learn the right way. Science teaches you a lot of things. Okay, I hope no parents listening to me. Any of your parents listening to teacher or not? Am I teaching any parent? God. Okay, thankfully. Okay, so in humidity. Uh-oh. I've got somebody's mommy listening. Okay, your mother will be happy with me. I'm teaching you all how to dry the clothes. Okay. All right. Now, for humidity, all right, the dry air is contains less water vapor. Okay, and when we have less water vapor, okay, what happens? Then therefore, okay. So when you talk about humidity, you must remember the air is very dry one. So that it's very dry. I don't have enough water vapor inside. So when I don't have enough water vapor inside, so this dry air can quickly hold in more water molecules that's escaping. Okay, that means to say, because it's so dry, water molecules can come into that dry air. Okay, so the concept here is my rate of evaporation of water will increase. Okay, so evaporation can happen faster, okay, when my humidity decreases. Okay, when I have when it's less humid, my rate of evaporation increases. So we will do this experiment again on Friday. Teacher will give you 2 bell jars. And in that bell jar, I will have one water covered with the bell jar, another one anhydrous calcium chloride. Anhydrous means it's dry. Okay, now if I have a cobalt paper and if it's pink in color, it means water is present. If it's blue in color, it means water is absent. Okay, so now you look at beaker R and beaker S, or bell jar R and bell jar S. Okay, which one you think will turn blue first?
So R.
S, S.
S.
Because the calcium chloride can absorb moisture.
Okay, yes, okay, so because it is dry, okay, so this anhydrous calcium fluoride, okay, changes my wet cobalt chloride paper to blue, okay, because why? Water is being absent here. So S will turn blue first. Okay, it's dry, so it turns blue straight away. Here water is present, here already wet, so it doesn't do anything at all. Okay, it stays pink completely. Okay, you may not get the picture now, don't worry, when we do the experiment later, then you get the concept better. So the point to take note here is my rate of evaporation of water will increase okay, when my humidity decreases. Okay, When I can absorb water, that means my rate of evaporation will increase. Okay, so that's point number 1. Okay, look at the point number 2, my temperature here. When my surrounding temperature is increasing, okay, I gain more energy, I move faster, and I can escape into the air easily. Okay, imagine Prashina coming into the class, and that day I'm very happy. Okay, and then I don't scold y'all. All of y'all will do your work smiling and maybe take your time and all, correct or not? But what if I come into the class and I'm super angry? Y'all didn't finish my work on time. What will happen to y'all? Y'all will sit down quietly, finish my work in God's speed, isn't it? Am I right or not?
Yes, sure.
Correct, right? So that's the concept. When maybe Pranat say, Pranat, I'll try that on you, Pranat. Okay, so when the surrounding temperature increases, okay, normally, okay, you gain more energy, you'll move faster, and you will escape into the air easily. Okay, so when my temperature increases, my rate of evaporation also increases. Okay, so the experiment is this. Look, one has light, one has no light. Both also got wet pink cobalt chloride paper. You tell me, common sense. Okay, which one will turn blue first? K or J?
Okay.
Very good. See, you all are very smart. You all get the concept very quick already. Correct. Okay. K, I got K, I got higher temperature. Okay, so it will turn blue first. Correct. Okay. So the key point here is rate of evaporation increases when my surrounding temperature increases. So it's no brainer. Anybody go and put the clothes to dry outside when it is going to rain? Nobody, right? But if it's
No one,
nice,
sir.
no one. Okay, if you put the clothes to dry when it's going to rain, don't know lah, don't know what to say about you lah. But if you know it's nice hot sun like today, right? Your temperature is increasing. So therefore, you know that the clothes that you want to dry, the water will evaporate faster. Okay, so the concept is the same here. Same thing when you're blow drying your hair. Anybody blows dries the hair with cool air? Anyone here does that? I need to have a chat with you. Okay, thankfully, no. Okay. Oh, most of us, when we blow dry our hair, we use hot air. Yeah. So that's the same concept. Okay, let's move on. I gave you 3 concepts already, 2 concepts. Now let's go to the third concept. Okay, exposed surface area. Okay, this one all your parents will be happy with me for teaching you. Exposed surface area of water that is larger allows more water molecules to escape. Okay, so the rate of evaporation will increase when the surface area increases. Okay, so again, I show you the experiment. When you see the experiment, then you understand better. Okay, teacher has, correct, Rosie. Okay, let's say teacher has PQR. Now my concept is the more surface area, the higher the rate of reaction. Okay, so which one do you think here will have the highest rate of reaction here, or highest rate of evaporation? P, Q, or R?
P, sir.
Okay, correct. Your answer is P. Yeah? P, the concept is when your exposed surface area increases, okay, your rate of evaporation also increases. Okay, and the last thing, blow, wind, blow, yeah? Your movement of air, okay? Your movement of air will sweep away the water vapor in the air. Now, please, don't go and practice in front of you blowing some air. No need to do that. Okay, high speed of wind will cause the air of the surface of the water to dry. Anyone I said don't do purposely, you did? Raise up your hand. I know some of you would have done. Funny lah, you children. Okay, so the rate of evaporation of water will increase when the movement of air increases. Okay, this experiment also very simple. Okay, one teacher has a moving fan, which is on M. Slide M has a moving fan, and slide N is away from the fan. Okay. Now, question. Sorry, I will show the answer. Yeah. Which one will turn blue first? Again, it will be M because I have the moving fan. Okay. Because I have movement of wind, the rate of evaporation is faster. Okay, the one that is N without the movement of wind, the rate of evaporation is slower. Thank you for answering. So many of you are doing so well. Okay, we're almost done with this slide already. So one of you take a photo of this and send it into the group now. So this is actually the main focus of what I just taught you. When my humidity increases, my rate of evaporation will decrease. But for everything else, if my temperature increases, evaporation increases. When my surface area increases, my rate of evaporation increases. Thank you. When my movement of air increases, my rate of evaporation increases. Okay, so these are the basic concept that you need to know. Now, next question they like to ask you. Okay, before that we play a game first. Again, still on class point. Okay, listen to what you need to do. Write your name, and then I don't know if they allow you to write all four. But if you're not able to write all four of the factors, write one is enough. Emmanuel, don't just write your name. Write your name and the factor. Are you part of the factor, Emmanuel? Darlings. Okay, you know what? Don't write your name. Just give me the factor. Okay, look at what Irfan did. Correct. Okay, Irfan, movement tu tak betul sangat. Dia movement of what? Okay, humidity somebody wrote. Correct. Exposed surface area, water, correct. Surrounding temperature, correct. Humidity, wind, speed, surface area, okay, good. Humidity, wind, exposure of surface area, okay. Anyone else? Am I waiting for anyone else? No one, yeah? Everybody okay already? Anybody still putting in your answers? Going once? Going twice? Okay. All right, did you a close submission? Yeah, I don't see any other answers coming along. Okay, surrounding temperature, yes. Okay, good. Movement, temperature, surface area, humidity, perfect. Yeah. Okay, all of you give very good answers. Okay, teacher put into my slide also as well. Okay, my next point to you here is, okay, how do I apply this into my daily life? This one is very important. Okay, this is the one your mom should be very happy that I'm teaching you. When you put your clothes to dry, okay, some of you, you don't put it like this clothes here, okay? You need to put it at the tip. Some of you put it in the middle. When you put it in the middle and you hang it in the middle and you clip it in the middle, then the other side doesn't get dried. Okay, so you always have to clip it at the top. Okay, so more surface area are being exposed here. All right, so clothes will dry faster. How many of you learned something new from Puan Sheena today on how to dry clothes? Okay, excellent. All right, okay, so good job. I hope your parents come and tell me, Puan Sheena, thank you for teaching. Okay, no. Okay, all right. Let's go on to the next one. Okay, how do we actually get salt? Okay, how Peanut butter? Why peanut butter, Lucas?
Planet's name, sir.
Sorry?
That's short name.
What?
It's Pranat's nickname.
Oh,
Planet's
Pranat's
name,
nickname.
sir.
Oh, okay,
Planet
okay.
Nut.
Okay, sorry. Peanut butter is your nickname. Okay, so when we want to get salt, sea salt, we also evaporate the sea water. Actually, when I teach you chemistry next time, I will also do this with you. Okay, I'll give you copper 2 sulfate. It's in a solution form. Then we will evaporate it. And then you will get the crystals of copper 2 sulfate blue in color. Okay, you all wait till you come Form 4. Teacher teach your chemistry. Okay, so that's evaporation as well. Different kind of salts. Okay, who likes to eat this? Oh, no one. Good. All of you healthy children. Okay. So when I dry a seafood, okay, Aisha likes to eat this. All right. Okay. All right. It can be kept longer because microorganisms cannot survive, okay, without water. Okay. So these are some ways we can preserve food up. We dry them up. Okay. So we want to blow dry your hair as well. When we have a hot temperature, okay, it will increase the evaporation of water. Okay, now this one we don't have to waste time. I think you all answered already, so we don't have to do this question. I am going to go to my next slide already. Okay, the next slide is pretty interesting, and actually I wanted to make mayonnaise with you all in school. So see whether teacher got time on Friday. Okay, we can bring mayonnaise. We can make mayonnaise in school. Have you all made mayonnaise before in your entire life?
No, teacher.
Okay, do you all know mayonnaise is made out of what?
Milk.
Okay, do you all want to know the truth?
Yes.
Mayonnaise is actually made out of a lot of oil and water. Okay, and they actually just oil and water. That's it. But because it is heterogeneous, that means it's two different solutions. For it to become one solution, teacher put in a thickener, or teacher put in something to make it join together, which is egg or lecithin. Okay, so we will try maybe on Friday. Really, I've done it with my Form 2 kids before. Okay, I don't have it in this slide. It is in my Form 5 slide when I teach chemistry. Okay, when I teach them how to make mayonnaise. Okay, it is actually oil and water. Welcome to the real world. Okay. Lot of things that we eat these days are not really good. Yeah. So those of you who like mayonnaise, please take note. You're actually eating oil. All right. Okay. So this one is very simple. Teacher don't want to waste time. Okay. Yeah, McDonald's all cannot. Okay, now stop chatting already. Yeah, teacher want to start teaching. All of you listen. After this, we are going to play one quizzes. All right. So this is very fast. Okay, I've got a solute, I have got a solvent, and then I've got a solution. Okay, solute is a substance that can dissolve into a liquid. So I give you another example. Okay, here the example is sugar. But many of you know, what's my favorite drink?
Sugar water.
No,
Orange juice.
no.
Salt water.
Okay, I do like water. Okay, but anyway, maybe I didn't teach you last year. One of the favorite things that I like to drink is either chocolate, hot chocolate, or Milo. Okay, so I'm going to use the solute as Milo. Okay, solute is a substance that can dissolve into a liquid. Okay, so imagine this sugar here is a solute. My Milo powder is a solute. Okay, and the solvent is a liquid that dissolves a substance. So a solvent is usually either water or an organic solvent. That's it. That's the two solvents you will learn in your entire life. Don't get confused with any other solvents. So right now, the solvent that teacher's teaching you is water, the very famous one. And a solvent is always going to be a liquid. Now, when a solute goes into a solvent, it becomes a solution. For example, Milo powder goes into water, it becomes Milo drink. Okay, so a solution is the mixture that is formed when the solute dissolves in a solvent. Okay, so I don't think what I'm saying here is anything difficult. So I do not want to waste time on something that is simple. Why I use Milo? Because I can talk about dilute Milo and I can talk about concentrated Milo. Okay, so there was one day when I was preparing Milo for my eldest son. Okay, and my eldest son said, "Mommy, your Milo tastes like poor Milo." So I said, "Jude, what do you mean by poor Milo?" Not enough Milo, mommy. Okay, not enough Milo powder. Okay, so got poor Milo and rich Milo. Okay, don't play. So dilute solution is when you've got poor Milo. Okay, take note. I've got very little amount of solute in that solvent. Okay, so I can dissolve more solute. Okay, it's as though you cannot drink any Milo there. All right. Okay, now you are like me, okay, and then be careful if you're like me. You can get instant diabetes if you take too much of Milo, but I try not to take too much. Okay, how many of you like Milo dinosaur?
Milo
Okay, before we
dinosaurs
go,
what?
okay, before we go to Milo dinosaur, we do Milo cow first. Okay, Milo cow is when I've got more amount of solute in the solvent. Okay, I've got a lot of solute. That means I've got quite a bit. Okay, and I can dissolve less solute. Okay, that means it's already quite concentrated already, very cow already. I'm sure you all know the definition of cow, isn't it? You all know what's the meaning of cow? Not the cow, not the real cow, okay? Sekali. Okay. All right. Okay. So it means to say, when you put in the Milo already, you cannot stir anymore already. It's like enough already. Cukup already. That is concentrated solution. Saturated solution, full lama. It's your Milo dinosaur. Who doesn't know what Milo dinosaur is? Milo dinosaur is actually when you have normal concentrated solution already, and then on top of that Milo, you got Milo powder. Oi, here all powder. This one confirm instant diabetes. That one not just diabetes, instant diabetes. Terus dapat diabetes if you take Milo dinosaur every single day. Okay, and you've got, so what's the point here? I've got excess amount of solute, too much. Already here so concentrated. On top, you go and put Milo powder some more. Okay, I cannot dissolve any more solute, and therefore it forms a precipitate. Okay, that's why when you have a lot of Milo powder, and when you want to stir, you can't stir anymore. You keep getting the Milo powder. That's called Milo dinosaur. Too much. Those of you who have never tried Milo dinosaur before, please go and try just for today. Okay, okay, somebody showing Milo dinosaur. Yes, that is Milo dinosaur. Okay, thank you, Pranat. Pranat. Okay, all right. So he shared with you all Milo dinosaur in the group. Okay, so let's talk about solution and suspension. Now, imagine, oops, sorry. Sorry, what happened? Wait, sorry, children. Now imagine this sugar is now sand. Okay, when I put sand into a water, will it dissolve? Well, y'all lost your mouth or something like that. All of y'all don't know how
No,
to
teacher.
Nurture.
Apalah y'all ni. Okay, very good. It's no. So when something doesn't dissolve, like when I put sugar in water, when I put Milo in water, it dissolves. But when something doesn't dissolve, I call it a suspension. Okay, I get a cloudy mixture formed from an undissolved solute particles in a solvent. Okay, so what's the difference? Okay, so the difference is this. If it's a solution, it will dissolve and it's clear. If it is a suspension, it's cloudy and it is undissolved. Okay, that's the difference between the solution and a suspension. Now, a solution can allow the light to pass through. You go and do your own experiment at home. One day or Friday, if you got time, you can do. You put sugar into water, you pass through the light there, the light will pass through. But if you take a mixture or sand and water, the suspension will prevent the light from passing through, cannot pass through. Okay, impossible. For a solution, because it is already dissolved, I will have no residue. Nothing is left when I filter it, nothing, because it's all dissolved. However, suspension, okay, for sure. Okay, the suspension for sure, there will be something dissolved. Sorry, there will be residue because, okay, here teacher got sand left, okay, and I can filter that sand off. Okay, so this is some of the differences. Okay, a solution, okay, it will not settle if left undisturbed. Okay, but if suspension, it will settle down. See, it will eventually, the sand all will form at the bottom here. Okay, if it is left undisturbed. How many of you love bubble tea? How
Me,
many of
teacher.
you? When you all drink bubble tea, kan? Okay, when you all drink bubble tea, if you don't leave it disturbed, what happens to your bubble tea at the bottom? What will happen to all your bubble, this one, all this thingy here? It will stay at the bottom there, right?
Yes,
Correct or
teacher.
not? Yeah, okay. Yes. Pernat, do you raise your hand, Pernat? Okay, but the solution, okay, if you see, it will not, nothing will happen. Okay, there's nothing for it to settle because they are all dissolved. Okay, now let's look at milk. Is milk a solution? Is milk a suspension? What is milk? Wrong. Okay, it's not a solution, it's not a suspension.
It's a
Okay,
colloid, teacher.
very good. It's actually called a colloid. Okay, so it's actually when I have two or more solutes, okay, it is dispersed evenly in a solvent and I don't get a clear mixture. See, milk is not clear, but I don't get a precipitate in as well. So a colloid is actually an intermediate between a solution and a suspension. It's not settling down, nothing suspended, but it's also not clear. Okay, so it's called a colloid. Okay, so let's see the difference between a solution. Solution, all clear. Suspension, something in the at the bottom. Colloid, okay, is not very clear, but it doesn't have too much of precipitate like a suspension as well. So here teacher calls it an intermediate. Okay, so take note, milk is an intermediate. Where can I find colloids in my life every single day? Milk. Your shaving cream, the cream that you put for your face, boys, your mayonnaise, okay? Okay, those are colloids in your everyday life. Okay, I actually have a quizzes for you all that I wanted to play online, but then I think I rather finish 5.2 and then only teacher will play the game. Okay, let me just ask you all, let me just stop sharing my screen first. Anyone here happy to wait until 10:30? Teacher try and finish everything by 10:30.
So now it's 11.
Sorry, 11:30. I try to finish everything by 11:30. Then what I will do is, for whatever I shared with you all today, I will give all the quizzes. You all go and practice. Can or not?
Okay, teacher. Okay.
Can okay, teacher appreciate you all. You all are really, really nice children, good children. Okay, teacher try. We only have 4 more slides to go, and they're not difficult at all. Okay, the next slide is the easiest of them all. We're talking about water. That's it. Okay, actually, so easy the topic, no need to talk about it also. Okay, wait. So when teacher come back next week, if I got time, teacher will buy for your pizzas. Okay, we eat pizzas together, maybe on a Friday or the following week. Okay, because all of you all did so well coming to class today and doing a good job. Okay, you're sharing, you all are sacrificing your Saturdays to study. Teacher's very proud of you all. Okay. Okay, so this one is super easy. Okay, now remember I told you just now water is a solvent, right? And then remember I told you that another solvent that you will learn in your life is organic solvent. So today teacher want to talk to you about water, and I want to talk to you about that organic solvent. Okay, let's do that. So it won't even take 5 minutes to teach you this one. Okay, now water is known as a universal solvent. It can dissolve almost anything. You want to wash something off, you use water. Okay, can dissolve solid, can dissolve liquid. Okay, it can dissolve gases also as well. I can use it any single area, so many places. Okay, industry, agriculture, medicine. Okay, so you and I know. I use it for cooking, I use it for bathing, I use it for cleaning. Okay, I can use it for, I can dissolve seasoning, I can dissolve detergent, I can dissolve soap. Okay, in so many ways, teacher can use water. Okay, I also can use, aquatic organisms also use the oxygen and carbon dioxide. Where are they being dissolved? They are dissolved in water. Okay, for the respiration and photosynthesis. Okay, so water is also very important for the aquatic organisms here. Okay, all right. Listen, teachers hoping everyone can listen. Okay, no chatting, no messaging one another. Okay, so water here can dissolve oxygen. Water here can dissolve carbon dioxide. Okay, especially carbon dioxide. Carbon dioxide is very soluble in water. Okay, here we see in agriculture, fertilizers will dissolve in water and therefore it will be absorbed by the root of our plants. Okay, so we use water a lot. How many of you like this? No one likes gassy drinks. Impossible. You all are telling lies, I'm very sure. No one in this class likes gassy drinks. Okay, not Vignesh. Okay, like the Coke, but not the rest. Okay, all right. So what is the soft drinks? Okay, I'm using water as my solvent. Okay, so I'm just showing you here so many places where there's water. Now look at this. This is paint. Am I using water here?
No, sir.
No. Okay, cannot. Okay, so here, right, I have something called an organic solvent. Okay, they are carbon based. Okay, they can be used to dissolve solutes that are insoluble in water. Okay, imagine you get yourself you dirty your hands with paint lah. Okay, can you go and just wash it off with water? Does it work all the time? Or especially something that we always do in class, some teacher will take the permanent marker pen. I don't know whether I've done it in your class or not. And then we go and write on the board with the permanent marker pen. Can I take water and erase it?
Cannot, sir.
Cannot. Okay, it's not possible because I'm using an organic substance there. Okay, anything that has an organic substance, okay, I must use an organic solvent. I give you another example. You see my fingers here. What color are they? Oi, my fingers blue color, not the one on the screen lah. My goodness, Arvin. Teacher's
Sir, your
fingers.
fingernails is
Oh,
red.
sorry, my fingernails. My brain not working today. Pink. Okay, some say pink, some say red. Okay, my fingernails. Okay. Can I use water to take it out? Let's say I want to take it out. Can I use water? Cannot. Why not? Why can't I use water?
Because it's insoluble to water.
Very good. It is insoluble in water. So I need an organic solvent to take it out. What is that inorganic solvent to take it out? Yes, I need to use a
Acetone.
nail varnish or nail varnish remover. Correct. And that nail, remove the nail, Sarvin. I'm going to shoot you or what? Sharvin, when I come back to school on Tuesday, get ready some hammers and all. Let me try removing your nail. Let me see how it goes for you. Okay, so point to take note, yeah. Anything that is anything that is not soluble in water, I can remove them using organic solvent. So even the thing that I told you just now, when a teacher use a permanent marker pen, okay, how to remove it? Okay, those days when we have no sanitizer, we actually go and take a thinner, okay, and erase it, okay. But nowadays, if you've got sanitizer in class, all you have to do is to take the sanitizer because it's alcohol based, it's carbon based. You spray on it, okay, because alcohol is a organic solvent, and it will come out. So teacher's teaching you another trick here as well, okay. Remember, if you have a permanent marker pen that you want to take out, you can use a sanitizer as well, okay. What do you want to break, Sarvin?
His hand.
Sarvin, no, I'm not going to do anything to his hand. Sarvin, don't worry, your hand's going to be fine, okay. Okay, so these are examples of organic solvent, like I told you just now. Alcohol, see, got hand sanitizer here. Okay, perfumes, okay, they're organic solvents. Kerosenes, okay, they're organic solvents. I don't know if you know this, but in your aeroplanes, you're not using petrols, okay. In your aeroplanes, we actually use kerosenes. That's your fuel for aeroplane. Just giving you some extra information here. Okay. Sorry. Okay. Wait, children. Okay, acetone. Okay. So your nail varnish. Okay, your lacquer here. Okay, all of them here. Your turpentine. Okay, you want to your paint remover, your paint thinner, ether, your oil extractor. Teachers going fast because all these are just examples. Okay, what do you need to know about organic solvents? They are volatile. Teacher, what's the meaning of volatile? They've got low melting and boiling point. So they will mainly boiling point. So they will evaporate easily. So if you put a perfume, okay, out in the open, let's say a little bit, over time, you will notice the perfume will become lesser, the content, the volume will become lesser because it has evaporated. Okay, so because of this function, okay, we use them, this enables them to be used widely in manufacturing aerosol substances, okay, such as spray paint, perfumes, and pesticide. Because they are so volatile, I can use them as an aerosol substances. That's why you always see them in this form, okay, as aerosols. We must always handle them very carefully because if not, it's harmful to us. Okay, so I told you, see, it's very fast. Okay, this subtopic is super duper easy. Okay, anyone has any questions? Teacher got 3 more slides. Anyone fainted already? Anyone feels that you are going to cry? You cannot cope? Okay. Yeah, still okay. Teacher still got 20 minutes. Anyone wants a 1-minute break to drink water? Okay, teacher just want to take something to drink, yeah? I just drink my cup of hot chocolate.
Can you
Okay.
for 1 minute?
Teacher give you a 1-minute break. For those of you who haven't taken your breakfast, teacher is very happy if you eat as I teach. I don't mind at all. Please eat. Go and take your food and come and sit down and listen to teacher. Anyway, you're doing nothing. Eat lah. Teacher's the one talking, not you. Rather you eat, your brains get full, your tummy get full, and then everybody's happy. At least 1.5 hours, you learn something, then your stomach also full. Then after that, the whole day you can relax. Okay. So anyone who needs to go and grab your food, please go and grab your food. Teacher's happy for that. Okay, today teacher talk about solubility and the rate of solubility. Now, what's the meaning of solubility? To the best of your understanding. All still taking the 1 minute break. Vignesh, if you're talking, you're muted. Teacher can't hear you. Okay, teacher, repeat again one more time. What do you think is solubility? So, okay, yes, correct. The maximum amount of time a substance will dissolve in a given amount of solvent, how fast a solute can dissolve, correct? Okay, all these answers are correct. Okay. Sorry, no copying people's answer. Huh? All right. Okay. Yes, so it is true. Actually, if you all type in the message, then teacher know you are here. If not, I wouldn't know you're in my class also. At least if you type something or if you say something, then it encourages teacher, oh, at least the child is in this class. Teacher appreciates that. Okay. So do respond so teacher will know that you are here. Okay. I'm just trying to adjust this chat box. Okay, so we look at solubility here. Okay, wait. The maximum amount of solute that can dissolve in 100 ml of solvent at a specific temperature. Will they ask this for exam? Will they ask you the definition? No. Okay, but you need to understand the concept. Okay, solute dissolving in solvent. Okay, solute dissolving in a solvent. That's solubility. Okay, and what are the factors that can affect the rate of solubility? Anyone? You just think about it. What can affect the rate of solubility? Who would like to try? It's okay, yeah, if your answer is wrong, teacher don't mind.
The size of the solute.
Okay,
The temperature of the water.
Okay, the
The
size
rate of mixture.
the rate of stirring. Okay, so yes, okay, all the answers are given there. Yeah, very good. To Emmanuel, to Rosie, to Vignesh, and Sarin, always going, yeah, copying everyone's answer. Okay. Sarvin, you're saying yeah for? Sarvin don't know what to say already. Okay, so we look at the three factors that teacher has here. Temperature, the rate of stirring, and the size of the solute. Okay. Okay, all right. If you want to say it out loud faster. Okay, so we look at the factors here. Not difficult at all. So we compare something hot and something cold. Which one will be soluble faster, in the hot water or in the cold water?
Hot water.
Hot water.
Very good, common sense, yeah. Okay, so we're going to see here the experiment we have here is, okay, teacher has salt in hot water, I'm heating up the water, and then I have salt in just normal water, normal 100 ml, both also 100 ml distilled water. Okay, we notice that when I have hot water, okay, my salt will dissolve faster. You can try this at home. You can tell your parents, Ponchina asked me to do experiment at home. Go and take something with hot water, cold water. Don't burn yourself, okay? And then put the blame on me, please. You're big boys and big girls already, okay? All right, and then you try the other one without, okay? So the higher the temperature, the higher the rate of solubility. Because when it is hot, okay, it becomes soluble faster, okay? So that's the concept that you are going to understand. Okay, that's temperature. Okay, the second one that we are going to do with you is stirring. Okay, now this one also no brainer lah. If you've got one that you stir very fast and then another one that you stir very slow, which one going to be soluble faster?
When you mix it faster,
Very good. Okay, when you stir faster. Okay. All right. So beaker L will dissolve faster, obviously, because I'm stirring it fast. So the higher the rate of stirring, the higher the rate of solubility. Okay, very good. Okay, so many of you are listening, paying attention. Okay, good. Okay, wait, putting Cairo in. Okay, last point. Sometimes when you press the wrong slide. Wait, sorry, children, sorry. Okay. Okay, look at this. Which one will dissolve faster?
The smaller one.
The smaller one, obviously. Who would like to eat this? How many of you like eating sugar?
Yeah, last time when I was a kid, I liked to eat sugar late at night.
My second son, John is his name. John likes to eat salt. And then recently, he likes to eat pepper. I have no idea why. Okay, he eats salt. Like if I want to cook something and then he wants to eat, Mommy, can I eat salt? Mommy, like eat salt like that. I look at him. Then that day I was giving him something. Oh, what? I gave him rice and chicken. Mommy, can I put pepper on the chicken? I'm like, okay. All right. Okay, Bernard likes to eat ice. Okay. All right. So anyway, side topic. I'll just give you all some information about my children to make the class a bit more interesting. Okay. If I've got big size solute and I've got small size solute, obviously the winner goes to the small size solute. Yeah. Okay. So we looked at the experiment. I've got 1 gram of fine sugar, 1 gram of sugar cube. Okay, the beaker K will dissolve faster than beaker L. Okay, so the smaller the size, the higher the rate of solubility. So as I said, today's lesson is not very difficult. Many of them is just common sense. Okay, okay. Why? Let's talk about the reasoning. When teacher have high temperature, okay, so my rate of stirring is higher. Okay, the particles can move very rapidly. Okay, when the particles are moving very rapidly, okay, the particles of the solvent and the solute will fill up the spaces between them faster. Okay, so they're moving very fast. So they're filling up all the spaces together. Therefore, the rate of solubility is higher. Okay, now let's talk about size. When I have the smaller the size, okay, always remember, when my size is smaller, I've got. So what do you mean by that? Okay, very simple. Okay, here, okay, ways teacher, the reaction can happen here. Can you hear? So many ways the reaction can happen. So many ways I can stir them and all get stirred. Now you look at the cube. Teacher can only hit it this way. I can only hit it this way. I can only hit it. Very limited for teacher to hit it. Here I can hit here. Everywhere on this, my surface area is so much in comparison to my cube. Okay, so the key point here is the smaller the size, okay, the bigger the surface area. Another concept will be, I give you a bigger picture concept, then you understand. If I want to roast a chicken, does roasting a big chicken or roasting just chicken drumstick, which one takes a longer time or shorter time to cook?
the chicken leg here.
Sorry, who said what?
The chicken leg will take a shorter time to.
Very good. Chicken drumstick, okay, will take shorter time to cook. Why? Because chicken drumstick has a smaller size, okay? I'm not good at drawing, don't laugh at teacher's chicken drumstick here, okay? This is my chicken drumstick, okay? So many areas where the heat can be, okay, and work on it and heat it up. Teacher's big chicken, this is the leg, okay? Sorry, I'm not good at drawing chicken also, okay? So the heat can only hit at these areas. So you come and you will see that when I have a smaller size, my total surface area exposed is larger. Okay, so do you get the concept? Potato with legs. Oi, not funny, Sarvin. Sarvin very sarcastic today, Sarvin. I'll see you on Tuesday, Sarvin. See what I'll do for you. Okay, I'm almost there. Teacher's got 5 more minutes and I'm almost finishing, okay? So I'm going to do with you water purification and then water supply system. Okay, this one is just 9 slides. Okay, all still alive? If you're alive, type 1 in the group, in the chat. If you're still alive, type 1. Jonathan type 2, Emmanuel type 2. Emmanuel, I didn't ask to type 2 also. I just said type 1. See? Some of y'all don't understand English. I should start speaking in a different language. Okay, so let's talk about water purification. How many of you would like to drink this water here? No one, because there got a lot of microorganisms here, got a lot of suspended particles here. And then you and I got a lot of dissolved substances that I cannot see, you cannot see. Okay, so what can we do? Okay, we need to purify it. I can do boiling, filtration, chlorination, and distillation. So 4 ways, yeah? So teacher want you to remember, you know, you all learn A, B, C, D, E, F, G. Okay, I'm not teaching you A, B, C, D, yeah? But just remember B, C, D, F. That's it. B, C, D, F. All right? B for boiling. See, I always told y'all, I like to teach your way to memorize. Okay, and I was not singing for y'all just now anyway, yeah? Chlorination, distillation, and filtration. Yeah, forget the A, forget the vowels. Okay, and there you go. You've got boiling, chlorination, distillation, and filtration. Can I have one person being brave enough? Your heart is beating very fast. You tell me all the 4 steps now.
Boiling, filtration.
Okay,
No,
finish. Okay, finish done 2 already. Finish done boiling, filtration. Okay, finish. Let somebody else try.
Chlorination and distillation.
Okay, I heard Sarvin and Rosie. Well done.
Boiling, chlorination, filtering, and distillation.
Okay, correct also. Ame, correct. Rosie, correct. Sarvin, correct. Jonathan, correct. Vignesh. Okay, well done. Okay, all right. Now let's see with these 4 steps that I told you all, what do they do for us actually? Now let's look at boiling. Boiling, I'm using high temperature, and memang boiling will kill the microorganisms. Okay, some countries like Australia they don't even have to boil water. They drink water from the tap, because that's how good their water system there is. Okay, Malaysia, you don't try that, and Puan Shina didn't teach you that. Please don't tell your parents Puan Shina taught you that. I never teach you ajaran sesat. All right, please boil water when you want to drink something. Okay, use distilled water. Right, so boiling, we use it to kill organisms. Okay, what happens here? The boiling will kill impurities like microorganisms, suspended particles, and dissolved substances. You must remember for each, what does boiling do? Okay, so they will do these 3 things. All right, okay, now let's go on to the, okay, sorry. Boiling, what will it do? I won't give you all the answer yet. Sorry. What does boiling do? Does it kill the microorganism? Obviously, yes, right? Okay. Does it do anything to your suspended particles? No. All right. Does it do anything to your dissolved substances? You lost your tongue or something like that. Okay. All right. So see the face there? Okay. Yes. For boiling, suspended particles, nothing. Dissolved substances, also nothing. It will only kill your microorganisms. Okay, so the key point is actually here. Now we look at the next one, filtration. Most of your houses will have filters. Okay, now, oops, what does filtration do? Okay, teacher showed the answer already. Okay, it does nothing for your microorganisms, but yes, there will not be any suspended particles, and it doesn't do anything to your dissolved substances as well. I don't know why my okay. All right. Did you get what teacher said for filtration? So filtration will only affect what?
Suspended particles.
Very good. Suspended particles. That means, will you be able to drink sand?
No.
No.
No. Okay. We're not going to drink sand for sure. Are we sure that there's no microorganisms in there? We're not sure. That's why you still must do boiling. Okay. And for your dissolved substances as well. Okay. Now, we look at chlorination. Okay. Chlorination usually happens in the pool. Okay. What does chlorination do? Tell teacher. Does it kill microorganisms?
Teacher, it removes the dissolved substances.
Okay, now it's very cost saving to cleanse a huge amount of water, especially in pools, yeah. But because chlorine is not very safe, it's quite harmful. Okay, so must be very careful. So for chlorination, it kills your microorganisms. Okay, nothing to your suspended particles, nothing also to your dissolved substances. Okay, so what happens here? It is for your microorganisms as well. So the teacher's done boiling, I've done filtration, I've done chlorination. We will do distillation now. Okay, distillation, I need a lot of energy, and this is a super slow process. Have you all done distillation? Have you all seen the process in Form 1 before? Has anyone taught you all?
Tuition teacher.
Have you all done the whole process?
No, sure, we didn't do the experiment yet.
Okay, memang cannot do the experiment, but we can do the demo. See one day if teacher can do the demo with you. Okay, there was once we used cold water also, or ice syrup or whatever we can use, and then we can see what happens. Okay, it's a very slow process.
Can't do the.
Normally distilled water,
How come we can't do the whole experiment?
we don't have the whole setup for 10 groups. We usually have normally one setup or two setups only,
Oh.
because I need water supply here and water supply here, so not enough. So in my chemistry lab, usually we will do, or science lab, we have the distillation. Okay, what does distillation do? It will kill the microorganisms. It will also take away all the suspended particles, and it is very important in dissolving substances. So that's why if you go and buy water, right? Normally if you read there, sometimes you say reverse osmosis, and then sometimes you will say distilled water, correct or not, class? Have you all bought water and then it says there distilled water? Yeah, okay, this is important because distilled water kills microorganisms. Okay, there are no suspended particles in it. Okay, and also none of these dissolved substances are in it also as well. Okay, correct. All right, okay. So let's see here. The good one that we see here is distillation. Everything is perfect. Okay, for microorganisms, for boiling, it just kills the microorganisms. For filtration, suspended particles. For chlorination, microorganisms as well. And distillation, it ticks all the boxes here. Okay, and do you all understand what teacher is saying?
Yes.
Yes, teacher.
Okay, now it's already 11:30 and I have one more slide to go, but I don't know if you all can cope. I don't know, it is if it's too much for you all already. Can or not? It's just one more and then we finish chapter 5 already. So, okay, you have to leave, it's fine, but teacher probably will just take 5 minutes for it. And don't worry, when I come back, whoever still who doesn't understand, they will still go through with you. But I just didn't, when I come back, I just want to start on chapter 6. I do not want your class to be late. Okay, I do not want y'all to be the one of the classes that doesn't be on par with the rest. Yeah, that's why teacher's doing this class. I am going fast, but teacher got no choice. Okay, last but not least. Okay, water supply. Okay. Now this one, you still have to read. I only can explain very fast. Okay. Okay, but you still have to read after I teach you today. Okay, so where does tap water come from? Look at the whole process here. Okay, so actually we're going to talk about our water supply system. Okay, so the water reservoir here, okay, we have all the water coming from there. So the first step that happens is we filter the water because as you can see, there's leaves there. Okay, so the first step here is we're going to remove large suspended particles like leaves and tree branches. Okay, and then we move on to oxidation. Okay, so after filtration, I remove all of that. Okay, it will go to the pump station and then we go to the next step, which is oxidation. Now, because you know water lah, sure got smell, right? So in this oxidation process, teacher will increase the oxygen content, not teacher, the whole water supply system thing, yeah? Because I want to get rid of any unpleasant smell and taste. Just like you, when y'all after your PJ, y'all don't smell so nice, right? What do y'all do?
Deal with it, sir.
You bear with it, yes, okay, but some of you don't bear with it. What do y'all spray on yourself?
Perfume.
Perfume, okay, y'all spray perfume on yourself. Same thing. Here, they in the oxidation compartment here, they will increase the oxygen content. So all this unpleasant smell and taste will leave. Okay, right after that, okay, we go to the coagulation. Okay, coagulation is when teacher add in alum. Okay, alum is a chemical so that the mud particles, okay, will stick together because I still have mud. Okay, and sink to the bottom of the tank. Okay, so what happens is teacher add in alum, it will, all the mud will go to the bottom of the tank. Okay, and then teacher put in slake lime. Calcium hydroxide is CaOH2. It is a base. Okay, because in the water sometimes got acid. So let's say teacher got acid here. Okay, and then teacher got base here. When the acid, sorry, when the base is added to the acid, okay, my acidity is reduced. So I don't have a lot of acid in the water. So two things are happening here. Okay, any mud particles, okay, will sink out. Okay, and then also teacher add calcium hydroxide, I will reduce the acidity. So when you drink the water, okay, you don't have a high acidity level content. Okay, so all this is happening when you're going to go through the whole water supply system. Okay, so this is what you see here from your coagulation just now. Now we go to sedimentation. Remember, you have the mud just now and everything. So all your mud particles now deposit, okay, at the bottom of the tank. Okay, they're all going to the bottom of the tank. So everything that is a sediment, anything that is suspended will not proceed to the next level. They will all go to the bottom of the tank. Here's your main part, which is your filtration. Any more smaller suspended particles that is not mud or whatever, they will go through the sand filter. So really fine ones, okay, will really go through the sand filter. Okay, and so your water that comes out, it will be very, very much more pure. Okay, then we have the chlorination and fluoridation. Very, very important here. Okay, teacher must add in chlorine. I told you just now already. Chlorine, teacher must kill the microorganisms. Must. Okay, if not, you can get sick. when you drink the water. Okay, and then teacher also puts in fluoride. You must put in fluoride because the water that we have there, if you don't put in fluoride, your teeth will become horrible. You look at people who live in the Ulu Fight area, very far away, you look at their teeth, you can tell, okay, that they are not drinking proper water, okay, or their water has not gone through the proper water system because their teeth does not show that. Okay, so we must add fluoride to prevent tooth decay. It comes out in exam, this question, teacher has seen many times before. Okay, from here, okay, after your chlorination and your fluoridation, okay, good ready, it's good to go. It goes to your clean water tank, it goes to your pump, it goes to your storage, and then it goes to your home. Okay, so now you know how actually the whole water supply system works. I would encourage you to read one more time. Teacher went through very fast with you. Do some questions. If you don't know anything, ask teacher. Teacher will help you. How many of you are like these people? Throw your stuff here and there and everywhere. Okay, no news means good news, yeah? Okay, no one answering me means you don't do that, right? Okay. Okay, so rivers are the main water source in Malaysia. So when you do water pollution like this, right, it's so difficult on the environment. Okay, so difficult. So how can we overcome it? Okay, we must have better sewage system. Okay, we must throw our rubbish properly. Okay, especially the sanitation facilities in the rural areas must make sure they teach them how to have proper sanitation, proper toilets and everything. How about industrial waste? People simply throw chemicals everywhere. Okay, we must put laws there. Okay, how they cannot pollute the water. Okay, because when they pollute the water, chemicals go into the water. So many children got sick, if not mistaken, during the MCO time in Johor. Okay, teachers got sick, students got sick. Yeah, can't remember when. Okay, and also chemicals in agriculture. Okay, we must teach the farmers to use good fertilizers, good pesticides, okay, so that they don't use the ones that is so harmful, okay, for us. When oil happen or oil spillage happen, we can actually surround and contain that oil. Okay, there's a way to do it. Okay, and then we can check. Okay, use air surveillance. Okay, if there's oil there, quickly make sure we know how to overcome this problem. And we are done. Amazingly, we have finished. Okay. I don't know if all of y'all are still here. All of y'all clapping your hands. Puan Shina actually